The first topic I want to discuss, to present, is the concept of measurement. Because I believe this is something that I have been insisting for quite some time, that there is a difference between collecting data that often are expressed in terms of numbers, and assuming that these data are measures of something. And my objective for today is to demonstrate to all of you that unfortunately this is not the case. Many times when we see numbers, when we see data, when we see the material that is produced during a data collection, field operation of a survey, or when we see variables that are disseminated with the material, the measurement problem have not started to be addressed yet. This is particularly true, or I would say specifically true, when we deal with human and social research. Because the things that we want to measure in the social and human research field are not directly observable attributes. Think about it. And we are in the area of two particularly important constructs. Resilience. What is resilience? Food insecurity. What is food insecurity? These are ideas. These are concepts. There is a technical term. These are constructs, mental constructs that we would like to measure, but we will never, ever observe the severity of the food insecurity, the ability of resilience, the resilience power or resilience capacity directly. So when we speak of measurement of these things, we need to understand that there is an additional step that goes from the moment in which we have data, information, can be qualitative, quantitative, represented through numbers, video, recorded material, anything. This is our data and the measure that we want. There is a process that only exists in the social and human research that requires that you transform the information you have into a measure. So the first lesson of this meeting today is, in human and social science, the measurement process starts after you have collected your data. Even if the data is recorded as numbers, it is not a measure. Having said that, I have to immediately qualify and say, in reality, no, because if you don't have a good idea of how to do this process after you will have collected the data, you probably will end up spending lots of resources and wasting a lot of resources in collecting data that is less than optimal. There is also an approach of saying, okay, let me see whatever data I have, and let me try to figure out whether I can get to a measure of resilience or a measure of food insecurity. But you will end up discovering that maybe some of this data is irrelevant, is not so useful, is less than optimal. And therefore, the process of measurement has also a feedback loop in which, by learning how to do this analysis, you improve your knowledge in terms of how to collect the data, which data to collect. So having said that, if you want to talk about something as being a measure, it is not enough that these things is expressed in numbers. Because sometimes numbers are just labels. Numbers can reflect simply an order, 1, 2, 3, 4, 5, maybe first, second, third, fourth, and fifth, rather than 1, 2, 3, 4, 5. They may be labels to just identify groups. 0 and 1 are two numbers that are often used to just identify yes and no, discrete qualitative classifications. So the question is, what is it that makes something a measure? In order to say that a specific measurement system produces a valid measure, it must be true that the numbers that you call your measure must be in a one-to-one correspondence with the attribute that you are trying to measure. Meaning that the numbers will differ, will change. The tool, your measurement instrument, will produce a different number if and only if the attribute changes its magnitude. And this must be a very precise relationship. Double the magnitude, the number should be twice as much. If the magnitude shrinks by 10%, the number should be lower by 10%. Otherwise, what you are producing is not a valid measure. So I'm giving you a definition of validity as defined into the metrology discipline, which is the science of how to come up with measures. I think many of you are familiar with the fact that even including during the MDG era, one indicator of food security was the prevalence of underweight children. Now, imagine the situation in which a child is sick and despite eating, he won't gain weight because he has a diarrhea, because he has some other condition, which means that if we measure anthropometry, height and weight of this child, the number may change even if the food security situation of the household where the child lives is not changing. So the information that is contained in the height and weight do not depend only on the food security, which means that while you can claim that in anthropometry, children anthropometry measure, there is some information that relates to food security, child anthropometry is not a valid measure of food security. So I'm also drawing here a distinction between a measure and an indicator. And the main purpose of these meetings would be to understand the difference. So the first property of a measure is validity. The second property of a measure is reliability. Reliability can be decomposed in two elements. One is precision or accuracy, and one is correctness or lack of bias. And sometimes there is confusion because some people use the expression reliability to refer only to precision. And so you need to be a little bit open-minded, understanding exactly what are we talking about to interpret the labels. But the concept is relatively simple. A measurement system, a measurement tool, can produce very precise measures, meaning that if you apply your measurement tool to a given object, the same object, again and again and again, the measures that you obtain are very similar to each other. Variations of the measure around the mean are very small and are not systematically in one or the other direction. This is the property of precision. Accuracy, if you want, even though, again, accuracy sometimes is referred to the other property. So, precision, but then we also need to have correctness. If you are measuring, like many of us in these days are monitoring their temperature, no? But I have tried with 2 different thermometers, and they systematically give me a different number. Even though each thermometer is very precise in the sense that if I take 3 measurements of my temperature now, the thermometer gives me 3 numbers that are very close. Using another thermometer, I have 3 very close numbers, but different. So there is a problem of calibration. There is a problem of accuracy in the sense of correctness. It cannot be that both thermometers are correct. One is correct, the other one is biased, or maybe both are biased. In order to evaluate the bias, one should have a gold standard of reference. Meaning that if I have the best thermometer ever built on Earth, I should take the temperature with that thermometer that becomes my gold standard. And then I can evaluate the accuracy or the correctness of my thermometer with reference to the measure produced on the same object by the gold standard. And this concept is, again, the combination of precision and accuracy determines the reliability. And this is a property not of one specific measure, it's a property of a measurement system, of a measurement instrument. To summarize, I think the 2 important properties that we need to recognize and be able to evaluate is a combination of validity and reliability. And reliability in itself is a combination of precision and accuracy. Sometimes it is better to be approximately right when you produce an assessment rather than pursuing a false sense of precision and producing results that are precisely wrong. Because in terms of the guidance that we need to give to policymakers, it's important to be approximately right and honest about the precision. So in this sense, what I'm saying is that good practice should always lead to attach to the figures also some indication of the residual margin of uncertainty that is unavoidable every time we make an assessment. When you put up a report in which you present the number of people up to the unit, 1,324,655 people, that is giving the wrong impression of high precision when in reality there is none. presenting the number in terms of intervals is always a better way to do this. Communication people find it difficult to properly convey uncertainty. I think most of us do not pay sufficient attention to communicating the uncertainty. And actually, in my opinion, statistics is not a branch of mathematics. Statistical is not learning on how to use some models and do some computation with random variables. No. Statistics should be a branch of philosophy, should be the thing that helps human beings to talk about, to discuss about things while recognizing uncertainty. Going back to the distinction between data and measure, going back to the problem of what happens when we have to measure things that we cannot observe directly, statistics is the tool that helps us to filter the noise from the signal. And noise makes it more difficult to understand exactly what's going on. And so I need something, a filter, that allows me to separate what is relevant, what is the signal, what is the information that the data is conveying, from what can be considered noise, disturbance, errors, accidents, whatever. This is what statistics is about. And now I conclude by saying, because of the nature of the things that we want to measure, the need for using statistical tools to transform the data into measure is fundamental. Okay, now let me stop here. Please raise your hands if you have a question.
Thank you very much, Carlo. You told about the two principles for the measurement. Told about validity and reliability. Yes, reliability. So for the reliability, you told about the necessity sometimes to calibrate the measure by using a gold standard. So my question is it always possible to have a gold standard for that kind of calibration?
Very, very good question. And the answer is no. There are cases in which a gold standard do not exist yet. And if you want to allow my pretentiousness, since 2015, we started creating the possibility of a gold standard for household or individual food security measurement. And this is because, thanks to the activities of the project Voices of the Hungry, we have been creating a global measurement scale for reference against which measures obtained in different contexts, in different countries, with different set of questions even, can be calibrated against. So the answer is no. There is not always a gold standard, and the objective of advancement of measurement into this field should be trying to establish the gold standard. Having said that, however, we need to recognize also that calibration against the gold standard and concluding about the reliability of a measure is much easier in the physical science. And it's much more complicated in the social sciences. And in some cases, and we will go into very deep detail, the validity question and the reliability question can only be addressed in probabilistic terms. So there will be never certainty on the measure of reliability, precision, absence of bias. There will always be a probability of bias. And even the validity question needs to be carefully thought of, because if I'm not sure about the number I see when I produce it, how can I say that it has doubled following doubling of the resilience ability or doubling of the food security situation of a household? So even the validity question will need to be addressed in a very special way that uses statistical theory in a very important sense. But this will be the main topic of, let me just anticipate, we will be talking about the rush model. The rush model is the way in which the concept of measurement has been transferred into the social and human science. So the first reference that I will share is actually a book called Applying the Rush Model, and the subtitle of this book is called Fundamental Measurement in the Human Sciences. Because that, Assad, is exactly addressing your correct question. Is it always possible to determine validity and reliability? Some people have even concluded, and this was true, I would say, around the 80s, 1980s, that measurement in the social and human science is not possible. Because you can never get to a gold standard, you can never get to a validity or an assessment of precision. So everything goes. From a philosophical point of view, I don't know if you're familiar with it, but there has been a postmodernist approach to inquiry in the social sciences that says everyone is entitled to his own opinion and there is no basis to distinguish which opinion is correct and which opinion is wrong. In this concept, there was a paper that became quite famous by Simon Maxwell. I think it's 1992, if I'm not mistaken, that speaks of the postmodernist view of food security assessment. But thankfully, that vision has been correctly overcome. And yes, while there still is considerable margin of uncertainty sometimes because we don't have enough information to make assessment, but the principle and the possibility, at least in principle, to say this is a valid measure, although is not very precise, and this is not a valid measure, the possibility exists. So this is what we will be learning. Thank you.
Thank you so much.